In this video, let's start talking about some additional Ansible 2.4 and Ansible 2.5 features. So Ansible 2.4 had quite a few features that actually were started and then basically sort of went nowhere. Basically, they started a few features, and we'll talk about these in more detail as we go along here, but they started a few features such as declarative intent, aggregate feature, and basically there was feedback on those features that there were some fundamental problems with them, or they were going to cause issues in one way, and they were sort of then put into a limbo state. Now, the ones they completed are actually there and exist and could potentially be useful. So we'll talk about them to a certain extent, but they are in this weird state where they were implemented for certain things and they're now there and they look like they're somewhat stranded. So we'll talk about the declarative intent modules, and we'll also talk about the aggregate feature as we go along. Now, besides those two features, Ansible also implemented additional modules for certain resources. So, for example, historically, if we go back in time, Arista had actually created a bunch of modules like EOS underscore VLAN, EOS underscore other feature, and they had a whole set of modules. And at one point, Arista actually deprecated those modules and stopped updating them. Now, some of these things have now come back into Ansible. So if you go and look at the Ansible networking modules, you're going to see a whole bunch of things beyond iOS command, iOS config, iOS fax. So there's now a whole bunch of additional modules like iOS interface. You can see that that was added in version 2.4. And if we go ahead and look at, let's go ahead and look at like iOS underscore static route. You can see that was also added in 2.4. So there was a whole bunch of these these feature-specific modules. Let's look at Arista as well. So here's a bunch of EOS. So there's something for VRFs. There's something for LLDPs. There's some interface modules. There's a system module. We go down to Junos. We'll see there's a bunch of Junos-specific modules. Nexus has always had a lot of modules, so there's been a lot of modules for Nexus for quite some times, but the general is in Ansible 2.4, 2.5, these numbers of resource modules have expanded, and you can try to implement specific features using those modules. So let's look at an example of that. So here I have the EOS system module. I'm going to configure on Arista 5. I'm going to configure the host name. I'm going to configure the domain name. I'm also going to configure some name servers. So as opposed to doing the generic EOS config, instead we're going to do this specific EOS system, set the host name, set the domain name, set the name servers. Once again, if we look at our inventory, we're using the standard Ansible 2.5 way of doing this. So we're going to use network CLI. So even though this is Arista, I'm actually using network CLI here, and I'm not using eAPI. So I'm using SSH, which is not great. In general, I'd rather be using eAPI where I can. Okay, so we're going to make this connection with Arista. We're going to be using network CLI. Here's my username and password. I've specified my network OS is EOS. So if I go ahead and execute my playbook, specify my inventory file, we can go ahead and configure those. Now here in a minute, that's going to have configured. We'll try to verify that the host name, the domain name, and those name servers are configured. Some of them I had previously configured, and there is an idempotency issue, I think, here with the host name that if I run this playbook again, it's actually going to say it changed every time. So now let's look at the running config using NetMiko's tools. I think this is PyNet Switch 5. And let's see what the host name, domain name, and name servers config currently looks like. Okay, so we see the host name wasn't set. Okay, I'm gonna have to look into that. Here's our domain name, test.example.com. Here's our VRFs. So I have to look at why the host name wasn't set to this. I don't know if that's a bug or something else is going on, but test.example.com and our name servers have been set. So here's our two name servers, here's our domain name. Okay, now let's look at this other resource module, this EOS VLAN 1.yaml. So once again, I'm going to make this 6 because I've already configured 5. So let's look at the show running config, the current state of Arista switch 6. Give it a minute here for this netmiko tools command to complete. So if we look at our VLAN configuration, you can see there are no current VLANs configured. So let's look at what we have here. So here I'm going to configure not an interface, but VLANs. I'm going to operate on PyNet switch 6. I'm going to turn off fact gathering. So once again, I'm using EOS_VLAN. I'm going to configure VLAN ID 400, give it a name, say it has to be there, so its state's going to be present. Now, this aggregate is a feature they added, that Ansible added in Ansible 2.4. And an aggregate is a way of configuring certain things, whereas opposed to using some looping structure, like a with items, where we went over this each time and configured it all individually. So we configured VLAN 403 with this name, VLAN 404 with this name, VLAN 405 with this name. The aggregate does that all at once. It is only available in some specific modules, and it's not most of them. It's just some subset of modules that have this capability, and it'll cause your playbook execution to be much more rapid when this exists. So aggregate is one of those features they introduced in Ansible 2.4 that now is largely in this state of limbo, in that it sounds like it's not going to be added going forward in Ansible 2.6 and later for new modules to have this capability. So, and then we get down to this last one, EOS VLAN. So VLAN 403 should already exist, and we're actually going to assign interfaces Ethernet 6 and 7. We're going to assign those two ports to VLAN ID 403. So let's go ahead and look at what happens when I run that playbook. Okay, so we're creating those VLANs. I think there's on the order of 6 VLANs that we're going to create. Some of them are going to be created individually at the top of the playbook. We're then going to get down to the aggregate. We're going to create 3 of them in one fell swoop. And then at the end, we're going to assign a couple of interfaces to VLAN 403. Okay, so created that first VLAN. While that's working, let me go ahead here and go ahead and log into the same server. Okay. Okay, it's creating the second VLAN. So while that's working, let's just go look at what we're doing. So we've created VLAN 400, we've created VLAN 401, we're now working on VLAN 402, that got created. We're now using the aggregate to create 403, 404, 405. Okay, that's done. And now we're doing the last task where we're assigning Ethernet 6 and Ethernet 7 to VLAN 403. So hopefully that's about done, and then we'll look at our configuration using netmiko tools to verify that those changes did in fact happen. Okay, so we go back to our netmiko tools command. looking at show run on the PyNet switch 6, also known as Arista 6. Go up and look at this configuration. We see we now have VLAN 400, 401, 402 with those names, 403, 404, 405, which came across with the aggregate configuration. We see Ethernet 6 and Ethernet 7 have been assigned to VLAN 403. So this does help us with the VLAN creation process, this EOS VLAN module. And then let's see what I have in this VLAN 2. So just to separate it out, the aggregate here. Now there is this interesting feature with some of the modules that support aggregate. They also have this purge capability. I don't really like the name aggregate, and I'm not sure I probably don't like the name purge either, but what purge basically says is that the set of VLANs has to exactly match this set. So any other VLAN besides these three will get removed. And now note, it doesn't actually affect VLAN ID 1, but I probably would in practice probably have that one as well. But it doesn't in practice affect VLAN ID 1. So VLAN 1, they won't try to remove. Okay, so at the end of executing this playbook, it's going to have 403, 404, 405, which it already has, but it's going to remove the other VLANs from the switch. So it's going to remove 400, 401, 402 because we have the purge true set. So let's go ahead and execute that playbook. That says create VLAN using aggregate, but in this situation, it's actually more of purging, removing the other VLANs from the configuration. This says configure interface, but that's a misnomer. We're actually doing the VLAN task. Okay, now let's go ahead and do our show run and see that we did in fact remove those other VLANs. Scroll up. So we see 403, 404, 405 is our set of VLANs. It removed the other three. I see that it didn't remove VLAN 1 because that's the VLAN that's used for these ports. And here you can see these two interfaces are still assigned to VLAN 403 that we did in that first playbook.